Hi, Mr. Wright here, and welcome to this film in which I worked my way through 50 grade 8 and 9 IGCSE maths exam questions. You can download the questions for free by hitting the link in the description, and then you can work on the questions before you watch the film, or you can be completing the questions as you watch the film and work alongside me. Entirely up to you. But if you hit the link in the description, you can download all 50 questions in one booklet for free, and that should help you out. Also in the booklet, you will find QR codes and hyperlinks every 10 questions to take you to the right place in this rather long solutions film. If you're finding the film useful, please hit like. Please tell me so in the comments. If you've got any questions, ask me in the comments, and of course I'll respond. And if you're preparing for your Edexcel IGCSE maths exams, two things you can do. Firstly, subscribe to the channel. There's lots on the channel to help you out. And secondly, hit the second link in the description and subscribe to my free newsletter, and then you'll be the first to know as I release new resources and new information that's pertinent to you as you prepare for your Edexcel IGCSE maths. Right, that's enough for now. Let's get on with the maths. Question 1. Right, this looks like a question about upper and lower bounds. Let's have a look. Right, we've got a formula for P, and then we're given A, C, and D, each one correct to a different degree of accuracy, and we're being asked to work out the upper bound for the value of P and to give our answer to 2 decimal places. Right, well, generally, with a question like this, before you do any more thinking, simply work out the upper and the lower bound of each of your variables. So A is 58.4, and that's correct to 3 significant figures. So my upper bound is going to be 58.45, and my lower bound 58.35. Let's have a look at C. Now C is 20, correct to 2 significant figures. So I'm going to go 20.5 and 19.5. And then I've got D, which is 3.6, correct to 2 significant figures. So 3.65 and 3.55. And now let's write down this formula for P. P is 2 times A minus C, all divided by D. Now I want the upper bound for P. So I'm going to put a up arrow there. Now if I want the upper bound, then I'm going to want the numerator here to be as high as possible. So I want the highest possible A's, and I want to subtract away the lowest possible C. And that will make the numerator as high as possible. And if I want the highest possible P, then I want to divide by the lowest possible number. So I'm going to choose the lowest possible D, because if I divide by a lower number, I get a higher answer. So that is what I'm going to need to substitute in here. Twice times the highest possible A, subtract the lowest possible C, all divided by the lowest possible D. Okay, so I'm going to put that in my calculator. I'm going to use the fraction function. 2 times 58.45 minus 19.5 and divide it by 3.55. Right, that gives me 27.4366 and so on. And I'm asked for the answer to 2 decimal places, so 27.44. And that is question 1. Question 2. Right, this looks like it's going to be a question involving circle theorems. And straight away I can see I've got a quadrilateral there, so I'm thinking about opposite angles in a cyclic quadrilateral, adding to 180. I've also got a tangent here, so I'm thinking about the alternate segment theorem as well, and I'm also thinking about the angle between a tangent and a radius equaling 90 degrees. Let's have a look. A, B, C, and D are points on a circle. Okay, that's how it looks on the diagram. TDV is a tangent. Yes, I clicked that. AB equals AD. Let's have a look. Oh, AB, that line, equals that line. Okay, so I've got the makings of an isosceles triangle, perhaps. Right, angle ADT is 90. Yep, is 71. Yes, that's marked. Work out the size of angle BCD. Right, this angle BCD, that is my target angle there. Okay. All right. Give a reason for each stage of your working. All right. Well, I've got the tangent there, haven't I? So if I were to draw a line from B to D, then I could use the alternate segment theorem. Look, that angle and that angle would be equal, wouldn't they? So my first piece of working is going to be that ABD equals 71, and I shall say alternate segment theorem. Okay, now that angle there then is 71. Right, so that means that this angle is also 71 because, of course, that's an isosceles triangle. So I'm going to say BDA equals 71 equals ABD isos triangle. Now, I can work out this top angle now. That angle there, can't I? Because that's angle DAB. That's going to be 180 minus the 71 minus the 71, because there are 180 degrees in a triangle. So that gives me 38 for that. And now I think I can find my target angle, which is BCD, because I've got 38 here and my target angle, and I know that opposite angles in a cyclic quadrilateral add to 180. So it's going to be 180 minus 38, 142. I could say opposite angles, cyclic quadrilateral, add to 180. And there is one of the possible ways of doing question 2. And BCD is 142 degrees. Question 3. Right, let's look at 3a first. I've got to simplify this algebraic fraction here. Now, first of all, I see it's the power of minus a quarter. So the first thing I'm going to do is I'm going to flip the fraction over, and now it will simply be to the power of a quarter. So that's made things simpler already. Now that's going to be the fourth root, isn't it, to the power of a quarter. So I'm going to need to have the fourth root of y to the 8 and the fourth root of 256 x to the power of 20. So when I'm finding the fourth root of y to the 8, I need to think about something times something times something times something is y to the 8. Well, that's going to be y squared. You divide the power by 4, don't you? Now here I've got the fourth root of 256. What times what times what times what is 256? Answer 4. And then what times what times what times what is x to the power of 20? We'll divide the power by 4, x to the power of 5. So that is part A. Now let's go on to part B. Right, we're subtracting fractions here, aren't we? Algebraic fractions. Now, before we get started, let's write these fractions in a somewhat simpler form. You see on the bottom there, I've got 9x squared minus 25. Well, that's the difference of two squares, because 9x is 3x squared and 25 is 5 squared. So that can be written as 1 over 3x plus 5, 3x minus 5. And let's have a look at this. Can I factorise the bottom there? Yes, I can. I can take a 2 out. Leaves me with 3x plus 5. Right. Now, if I'm going to subtract these fractions, then I need to be working with a common denominator. Let's have a think about the lowest common denominator I could be dealing with. Well, the lowest common denominator is going to be 2 lots of 3x plus 5 times my 3x minus 5. Now, let's look at this first fraction here. What's this denominator being multiplied by to get my new denominator? Answer, it's being multiplied by 2. So I must do the same to the top. 1 times 2 is 2. Minus. Now, let's look at this second fraction. What's this denominator been multiplied by to get my new denominator? Answer, it's been multiplied by 3x minus 5. So I must do the same to the top. 1 times 3x minus 5 is 3x minus 5. Now be careful to put that in a bracket because this minus sign here is going to have an effect on both the 3x and the minus 5. So what I'm going to have is I'm going to have 2 minus 3x plus 5 all over 2 lots of 3x plus 5, 3x minus 5. So that is going to be 7 minus 3x over 2 lots of 3x plus 5 and 3x minus 5. Now, yes, you could multiply out those brackets on the denominator, but you don't need to. You'll get full marks for that answer there. And that is question 3 sorted. Question 4, right, this is a question on coordinate geometry and it needs a bit of a think about before you dive in, I would suggest. Let's have a look. We're given the equation for line L and we're told some facts about line M. It goes through the point A and it goes through the point B. And look at this. L and M are perpendicular to each other. Work out the value of K. So I've got to work out the value of K. It would be useful, wouldn't it, to work out the value of K if I knew the equation of line M. If I could find the equation of M, then I can easily find the value of K because it's the y coordinate when x is minus 4. So I really need to find out the equation of M. Now, to find out the equation of a line, I need to know two things. I need to know a point on the line, and I need to know the gradient of the line. The equation of the line M is what I'm after. Do I know a point on the line M? Yes, I do. It goes through the point A, 5, 6. Do I know the gradient of the line M? Well, I don't, but I do know that the line M is perpendicular to L. So do I know the gradient of L? Well, I know the equation of L is 4y minus 6x equals 33. So if I rearrange that to make y the subject, then I'll be able to read off what the gradient is, because if y is the subject, then the gradient is simply the coefficient of x. So the gradient here is simply 3 over 2, look. So the gradient of L is 3 over 2. So the gradient of M, if M is perpendicular to L, the gradient of M will be the negative reciprocal. Look at that, minus 2/3. So I do know the gradient of M, and I do know a point on the line M. So now I can work out the equation of M. Equation of M. Right, I know it's going to be y equals mx plus c, and I know that little m there is the gradient, so it's going to be y equals minus 2/3 x plus c. And now I use the fact that I know that a point on the line is 5, 6. So I know that when x is 5, y has to be 6. So 6 has to equal 2/3 times 5 plus c. And that will enable me to find out what c is. Let's multiply everything by 3. So I get 18 equals minus 10 plus 3c. So I get 3c equals 28. So I get c equals 28 over 3. So now I know the equation of m is y equals minus 2/3 x plus 28 over 3. Now what was the question? The question was find k. And k is the y coordinate when x is minus 4. So let's put x as minus 4 in here, shall we? x equals minus 4. And let's use the equation of the line to find out what y would be. It's going to be minus 2 times minus 4 over 3 plus 28 over 3. So that's minus 8 over 3 plus 28. Sorry, it's plus 8 over 3. Minus 2 times minus 4 is plus 8 plus 28 over 3. So it's 36 over 3. It's 12. So when x is minus 4, y is 12. And to answer the question, k equals 12. So that was quite an involved question 4 there. It required us to find the equation of m and to use that to answer the question. And to find the equation of m, we need to know a point on the line m and also the gradient of the line m. And to find the gradient of the line m, we had to use the fact that it was perpendicular to the line L. Question 5. Right, let's have a look at this diagram first, and let's agree that we're likely to use the intersecting chord theorem. Okay, and now let's have a look. A, D, B, and E are points on the circle. Yes, they're labelled. A, F, B, C, O, E, C, and O, F, D are straight lines. Yes, they look like it. AF is 7, that's marked. FB is 4, that's marked. BC is 5, that's marked. FD is 2, that's marked. And CE is X, that's marked. Find the value of X. Show you're working clearly. Okay, right now. If we're going to use the intersecting chord theorem, we're obviously eventually going to use this line here and this line here. We're probably eventually going to use those intersecting chords, aren't we? Okay. And I notice the intersection is outside the circle, so that's quite fun. But before we do that, we're going to need to find out more side lengths, because before I use this chord here, I could really do with knowing the radius of the circle, these two lengths, or the diameter of the circle. So let's just go back a second and let's have a think about this chord here. Okay. All I know about that so far is that part of it is 2, and then the other part is the rest of the diameter of the circle. Let's call this point Z, just so we've got some way of referencing it. So if I think about DZ, now I could think about DZ alongside, alongside what? Well, I could think about it alongside AB. Look, there are 2 intersecting chords, and I know the lengths I need for AB. So let's set up that equation there, shall we? So I'm going to have AB and DZ. And I've got F and F and F and F multiplied and multiplied. So there's the intersecting chord theorem formula set up. Right, AF is 7 times BF is 4 equals DF is 2 and ZF, I don't know what that is, I'll just call it ZF. But look, I can find ZF now. 28 equals 2 times ZF. So ZF is 14. Right, so all the way from here to here is 14, which means that the whole of the diameter is 16. So I know the diameter of the circle is 16, the 14 plus this 2 here. So that means I now know the radius is 8. Now I think I'm in a position to use this intersecting chord here. These 2 intersecting chords here. I think I'm in a position to use that one because I know that this is 8 and that's 8 and that's X. And I think I can combine that one with AC, with this one. I'll draw it in blue. AC, right. So this time I have got chords as follows. I've got chord AB, and I've got chord, I haven't given this one a name, I'll call it Y. And I've got chord YE. And they intersect at the point C. C, 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 multiply, multiply. Right. Now, can I fill in the gaps here? Let's have a think. So A to C is 7 plus 4 plus 5, 16. Times B to C is 5 equals Y to C. Well, Y to C is 8 and 8 and x, isn't it? So that's 16 plus x multiplied by EC is x. Look at this. I think I'm going to get a quadratic equation. Let's have a look. So I've got 80 equals 16x plus x squared. So I've got x squared plus 16x minus 80 equals 0. So can I factorise this? I think I can. Let's have a look. Got to multiply to 80 and add to 16. 20 and 4 maybe, because one of them's plus, one of them's minus. Let's have a look. 20 and 4 plus 20 minus 4. That's going to give me minus 80 and it gives me plus 16. So look at that. My solutions are x is 4 or minus 20. So are there two answers then for x? Let's have a look at the diagram. Does it make sense for x to be negative 20? It doesn't. X is clearly a positive value. So x is minus 20 is not valid, meaning that the answer is that x is 4. So in question 5 there, we use the intersecting chord theorem twice. Once where the chords intersected within the circle at the point F, and on the second occasion where the chords intersected outside the circle at the point C. Question 6. Now, looking at the diagram here, I think we're going to be dealing with circle theorems. Okay, we're told that A, B, C, and D are points on this circle. That's how it's drawn. We've got a tangent to the circle, and look at that. We've got AB equaling CB. So we've got the makings of an isosceles triangle there, haven't we? Okay, let's draw this point here. Okay, now, now I've drawn that, I can see we might be dealing with alternate segment theorem as well. Right, angle BCQ is x, that's labelled already. Prove that angle CDA, that's this angle here. So that is our target. And we have to prove that that equals 2x. Let's have a look. Well, the first thing I reckon is that I can find this angle here, angle CAB. Well, that's x because of the alternate segment theorem. Okay, and now, therefore, this angle here is also going to be x, right? Because that's an isosceles triangle. So ACB equals x because ABC is isos. So that means that this angle here, ABC, is going to be 180 minus 2x, isn't it? Okay. Oh, now just a minute. You know how opposite angles in a cyclic quadrilateral have to add to 180? That means that this angle and this angle must add to 180. So ABC plus CDA have to equal 180. Opposite angles in a cyclic quadrilateral. I'll leave you to write that out in fullhand. So ABC is 180 minus 2x plus CDA has to equal 180. Well, therefore, CDA must equal 2x. There you are. Bob's your uncle. It's done. Prove that CDA is 2x. Give reasons for each stage of your working. That's question 6. Finished. Question 7. Looks like we're dealing with surds here. Show that the left-hand side equals the right-hand side. Show each stage of your working. Well, let's take this left-hand side then, and let's simplify it and see if we can't get the right-hand side as our answer. Okay, right, now, to start with, let's write that like this, and then expand the brackets. See what happens. So 6 sixes are 36, plus 6 times 2 root 12 is 12 root 12, plus 2 root 12 times 6 is 12 root 12, plus, and now I'm doing this, 2 root 12 times 2 root 12. Well, that's 4 times root 12 times root 12. Root 12 times root 12 is 12, so that's just 4 12s, 48. So now let's simplify this. Shall we? I've got 36 and 48, that's 70, 84, plus 24 root 12. Right. Well, I'm trying to get it equal to this, aren't I? So I suppose I could pull out a 12, because I can do 12 into 84, can't I, goes 7 times, and 12 into 24 root 12 goes 2 root 12. I'm almost there now. I've got the 12 outside, I've got the 7, it's just this bit. How am I going to get that? Aha, wait a second, I can simplify this root 12. Okay, let me show you how, in case you're not there already. It's going to be 7 plus, now 2 times, or root 12 is 4 times 3. And so you can write that as 12 lots of 7 plus. Now you can take that 4 out of the square root and square root it. So it ends up as a 2. So outside the square root, you'll have 2 times 2 is 4. And inside the square root, you'll have just 3. So there you go. I have shown that the left-hand side is equal to the right-hand side. Okay, let's have a look at part B. All right, I've got an algebraic fraction here, and the first thing I notice it's to a negative power. So I'm going to write down the reciprocal of that fraction. I'm going to flip it over, and now that is to a positive power. Okay, now I'm going to think about this as being t to the 15 to the power of 2/3 over 27a to the 12 raised to the power of 2/3. Now, if I look at the top there, when you've got something to the power of 15 and you raise that to the power of 2/3, then you simply end up with t to the power of 15 times 2/3. Those are your rules of indices, aren't they? And 15 times 2/3 is 10. So the top is simply t to the power of 10. Now the denominator, the bottom here, I've got 27 here to the power of 2/3. Well, that's going to be the cube root of 27 squared. So the cube root of 27 is 3, and if I square that, I get 9. So that was, let me write that down in case it makes it easier, the cube root of 27 squared. So the cube root of 27 is 3, square it, you get 9. Now what about this a to the 12 raised to the power of 2/3? Well, I'll just use my rules of indices again. And so it's going to be a to the power of 2 times 2/3, which is a to the power of 8. So there is my solution to part B. And I'm just having a quick look to see if I can do any more simplification, because sometimes they have a common denominator, common factor top and bottom, but they don't in this case. So that is question number 7 complete. Question 8. Okay, I've got the sector of a circle, OAB, and O is the centre of the circle, and that's an angle of x at the top there. And this sector is curved around so that OA meets OB, and it forms the curved surface of a cone. There you go. Now I'm told the height of the cone, and I'm also told the volume of the cone. Work out the value of x. Well, let's start out by using that fact we've been given about the volume of the cone. Now, the volume of the cone is 1600 cubic centimetres, and the formula for the volume of the cone is 1/3 pi r squared h, and I know that h is 25. So that means that I have this equation to solve for r. So I'm going to do 1600 times by 3 equals divide by 25 equals, and so I get 192, and I'll divide by pi, and that is r squared. So r is the square root of 192 over pi. Right, so that means that I know that length there, which means that I can find the length from O to A by using Pythagoras. Let's call that y for a moment. Okay, right, so y squared is going to be r squared, which is 192 over pi, square rooted, squared, plus 25 squared. So all I have to do on my calculator is 192 divided by pi equals, add on 25 squared equals, and square root my answer. And that tells me that y is 26.1938, dot, dot, dot. So that is the length from O to A, which is also the length from O to A and O to B on this diagram up the top. Ah, that's interesting, because now I can find an expression for this curved part of the circumference there, and also I know that that length from A to B is the same as this length from A to B. All on this bottom diagram here, it's the same as the circumference of that circle. So let's start with the circumference of that circle. C equals pi d. So the circumference is going to be pi times twice r, isn't it? So pi times 2 times the square root of 192 over pi. Well, I could obviously put a number on that if I wanted to. Let's do that, shall we? So it's going to be 192 divided by pi equals square root answer equals times by 2 equals times by pi equals 49.11968, and so on. And I know, therefore, using this diagram here, that that curved blue part of the circumference also has a length of 49.11968, and so on, and I know that equals x 360ths of pi times the diameter, where the diameter is twice that 26, isn't it? Pi times 2 times 26.1938. So I suspect that I've ended up with a formula here, an equation here I can solve for x. So I've got the 49.11968 on my calculator already, so times that by 360, divide it by 2, and divide it by 26.1938. Okay, and divide it by pi. Gives me x equals 107.443, and so on. I'm asked for the answer. Find x, give your answer correct to the nearest whole number. 107 centimetres is my answer for x. And that's question 8 done. Question 9. A frustrum is made by removing a small cone from a large cone. The cones are mathematically similar. Okay, I'm just looking at the picture here and taking it on board. The large cone has a base radius of r and a height h, that's mentioned there. Given that the volume of the frustrum is 98/125ths of the volume of the large cone. Well, it's all very well looking at the volume of the frustrum as a ratio of the volume of the large cone, or as a fraction of the volume of the large cone. But the frustrum and the large cone aren't similar, are they? It'd be much more pertinent to look at the volume of the cone that's being cut off and the volume of the large cone. You see, if the volume of the frustrum here, if that bit is 98/125ths, then the volume of that small cone on the top there must be the remainder, 27/125ths. So, if I were to think about the volume here, and let's take the large cone and the small cone, the one I've cut off, then I would multiply by 27 125ths there to go from volume of the large to volume of the small. So that means that if I was dealing with linear lengths, the scale factor would be the cube root, wouldn't it? So the cube root of 27 is 3, the cube root of 125 is 5. So if I was dealing with lengths, I'd be multiplying by 3/5, and if I was dealing with areas, I'd be multiplying by the square of that 9/25. Okay, now let's just go back to the question. Find an expression in terms of h for the height of the frustrum. Well, I can find an expression in terms of h for the height of the small cone. The height of the large cone is h, so the height of the small cone is 3/5 of h. Okay, so this height here is 3/5 of h, which means that the height of the frustrum must be the remainder, 2/5 of h. Okay, so height of frustrum equals 2/5 of h. And that was seemingly quite a complicated question until we broke it down into scale factors. Question 10. A solid is made from a hemisphere and a cylinder. Yep, I'm just looking at that. I've got the cylinder here, and there's the hemisphere, the half a sphere on the top. The plane face of the hemisphere coincides with the upper plane face of the cylinder. Yes, that's as it's drawn. The hemisphere and the cylinder have the same radius. Yep, that's as drawn. The ratio of the radius of the cylinder to the height of the cylinder is 1 to 3. So wait a minute. So if this is r here, then the height of the cylinder, not the height of the whole solid, the height of the cylinder must be 3r. Okay. Given that the solid has a volume of that, okay, well, let's write an expression for the volume of the solid, shall we? So, the volume of the solid, well, the volume of the solid will have the volume of the cylinder, well, the volume of the cylinder is pi r squared h, plus the volume of the hemisphere. Well, the volume of a whole sphere is 4/3 pi r cubed. We've only got half of it here, so I'll multiply that by half. So there's an expression for the volume of the whole solid, and I know that that equals 792 pi. Now, that h, I can do without that, because I know that h is 3 times r. So what I've actually got here is pi r squared times 3r plus, now 4/3 times a half, that's 4/6, pi r cubed equals 792 pi. Let's carry on. 3 pi r cubed plus 2/3 of pi r cubed is 792 pi. Let's divide everything by pi. 3r cubed plus 2/3 r cubed equals 792. Look at that. So 3 and 2/3 of r cubed is 792. Divide both sides by 3 and 2/3. R cubed is 216. Cube root both sides. R is 6. Right. Now I found the radius is 6. Now, easy to make a mistake now. Do you see here that it says work out the height of the solid? Now, the height of the solid is this length here. It's from the top of the solid to the bottom. So it includes up to here, which is 3r, and then that bit there, which is the radius in the hemisphere, isn't it? Another r. So the height of the whole solid is 4r, so 4 times 6, 24 centimetres. And that is question 10 done. Question 11. Okay, looks like a question on bounds here. I'm given a formula for p, and I'm asked to calculate the lower bound of p. Well, let's worry about that in a second. Let's write down the upper and the lower bound of each of my variables here. So x is 8, correct to one significant figure. So an upper bound and a lower bound. A is 4.6, correct to two significant figures, so an upper bound and a lower bound. And m is 20, correct to the nearest 10. Half of 10 is 5, so go up by 5 and go down by 5. Calculate the lower bound of p. Well, p is a divided by m minus x. We want p to be as low as possible. So we want the lowest possible numerator and the highest possible denominator. So we want m minus x to be as high as possible. So we'll take the highest m and the lowest x to make m minus x as high as possible. So that's going to be the lowest possible a, 4.55, divided by the highest possible m minus the lowest possible x. Right, so on my calculator, 4.55 on the numerator, 25 minus 7.5 on the denominator gives me 13/50ths, which of course you could write as 0.26 if you wanted to. And that is question 11 done. Question 12. The histogram shows information about the numbers of minutes some people waited to be served at the post office. Work out an estimate for the proportion of these people, so the fraction of the people who waited longer than 20 minutes. Well, here's my cutoff then for longer than 20 minutes. It's here, isn't it? So I want to know what fraction of all the people is that lot there. Well, let's work out the areas, because on a histogram the areas give you the frequency, don't they? So let's work out the areas of these bars here. So here, this one is 10 by 1, so it has an area of 10. Here we go, 5 by 1, an area of 5. 5 by 2.2, 11. 5 by 3.4, 17. What's that one? It's not 5, is it? It's 3. 3 by 4 is 12. And 2 by 2.5 is 5. Right, so the proportion of people who waited longer than 20 minutes, well, it's an area of 10 out of the whole area. Let's have a look. 17, 34, 35, 45, 50, 60. So it's 10/60ths of the area. And so the proportion of people is a sixth. Question 12 done. Question 13. There are 16 sweets in a bowl. Okay. 4 of the sweets are blackcurrant, 5 are lemon, and 7 are orange. Yes, that adds up to 16, so that's all the sweets. 3 people, A, R, and S, each take at random 1 sweet from the bowl. Work out the probability that the 5 lemon sweets are still in the bowl. Oh, wait a second. That means that none of them take a lemon sweet, doesn't it? So all I'm really being asked for is the probability that each of them, one after the other, take a sweet that isn't lemon. So Anna goes first. Her chance of taking a sweet that is not lemon. Let's have a look. 11 of them out of 16 aren't lemon, are they? So that's the chance of Anna taking a non-lemon. Right, next we have Ravi. Now when Ravi comes up, there are only 15 sweets left in the bowl, aren't there? And assuming Anna's taken a non-lemon, then there are only 10 more non-lemons for Ravi to choose from. And now Sam steps up. There are 14 sweets left in the bowl, and 9 of them are non-lemon. So the probability that there are 5 sweets still in the bowl is 990 over 16 times 15 times 14, 3,360. So if I put that in as a fraction, 3,360 gives me an answer of 32, no it doesn't, 33/112ths. And that is question 13 done, and I hope you avoided thinking about the probability of anything more complicated than you needed to. Question 14. Right, I've got 3 expressions here, and they are 3 consecutive terms in our arithmetic sequence. That means that 2x plus 23 is one term, the next term is 8x plus 2, and the term after that is 20x minus 52. And these are consecutive terms in an arithmetic sequence. If they're an arithmetic sequence, that means that the difference between that term and that term is the same as the difference between that term and that term. Prove the common difference is 12. So I've got to prove that the difference between the terms is 12. Well, let's have a look algebraically at the difference between the two terms. So the difference between the first and second term is going to be 8x plus 2 minus 2x plus 23. Put that in a bracket so I don't mess up the sign. So that's 8x plus 2 minus 2x minus 23. So that is 6x minus 21. That's the difference between those two terms. And the difference between the term at the end, which I call the third term, it probably isn't the third term, the third and the second term, is the third term minus the second term. Again, be careful with your brackets. 20x minus 52 minus 8x minus 2. 12x minus 54. Now, because this is an arithmetic sequence, I know that the differences, that and that, must be equal to each other. So I can say for sure that that equals that. So now I've got an equation I can solve for x. If I subtract 6x's from both sides and add 54 to both sides, then I get 33 equals 6x, or x equals 33 divided by 6, 5.5. Now I've got to prove the common difference is 12. There are 2 ways of doing this now. I've got an expression for the common difference. It's that or that. So I could substitute x is 5.5 into there and show it's 12, or into there and show it's 12, and that would be perfectly acceptable. Another way of doing it, which perhaps seems a bit more intuitive, is to use x is 5.5 to work out the value of each of the terms. You see, the first term is 2x plus 23. Well, if x is 5.5, then that gives you 34. The second term is 8x plus 2. But if x is 5.5, then 8 times 5.5 plus 2 is 46. And the third term is 20x minus 52. 20 times 5.5 equals minus 52 equals 58. And now you can see that the difference between the terms is indeed 12. And that's question 14 done. Question 15. Now this looks like a question involving vectors. Let's have a look. We've got a parallelogram, A, B, C, D, and we're told the vector from A to B, that's here, that vector is 2, 7, and we're also told the vector from A to C, so that's from A to C, that blue vector there, and that blue vector is 10 along and 11 up. Look at this, we're told the coordinates of point B as well. Point B has coordinates 5, 8. Work out the coordinates of point C. Well, we need to work out the coordinates of this point here. Well, I reckon that I can go from point B, which is 5, 8, and I reckon I can go from B down to A. I'm going to subtract the vector 2, 7, and that's going to give me the coordinates of A, and then I can make my way from A to C, because I know that from A to C I'll need to add on the vector 10, 11. So I'm going to add on 10 along and 11 up. So let's do that. So B subtract 2, 7 is going to give me the coordinates of the point A. So the point A is going to be at 3, 1. So that's the point A there at 3, 1. And now I simply need to add on the vector 10 along and 11 up to give me the coordinates of point C. So this point C is going to be 13, 12. So point C here is 13, 12. Okay, let's have a look at part B. Point E has coordinates 63, 211. Use a vector method to prove that ABE is a straight line. Right, I'm going to do this over here just so I can still see my diagram. So we've got point E with coordinates 63, 211, and we need to prove that A to B to E is a straight line. Okay. So, if we have a think about the vector from A to E, and we have a think about the vector from A to B, if A to E is a multiple of A to B, then ABE is a straight line. So let's find the vector from A to E. Now I know the coordinates of A are 3, 1, and I know the coordinates of E 63, 211. So to go from A to E, I'm going from 3 along to 63 along, so that's a horizontal movement of 60. And I'm going from 1 up to 211 up, so that's a vertical movement of 210. Meanwhile, I already know the vector AB. The vector AB is 2, 7. So let's have a look at whether or not AE is a multiple of AB. And it is, look, because 60 divided by 2 is 30, which is the same as 210 divided by 7. So I can say that AE equals 30 times AB, which means that ABE is a straight line. There we go. That is question 15 done. Question 16. Let's have a look at this one. Right. Mario is going to save £50 in the year 2021. He's going to continue to save up to and including the year 2070 by increasing the amount he saves each year by k. I think this is going to be arithmetic sequences going up by k each time. Mario will save a total of that much from 2021 to 2070. Work out the value of k. So let's have a think about this then. We've got the year 2021. Now in the year 2021, he's going to save 50. And then in the year 2022, he's going to save 50 plus k. And in the year 2023, he's going to save 50 plus k and plus another k. 50 plus 2k. And he's going to carry on all the way to the year 2070. So this is an arithmetic sequence, and the difference between the terms is k. All right. Now we're told that the total that he's going to save is $33,125. So we know the total of all of these terms, all the way up to that term there. We know what they all add up to. And we have a formula for the sum of an arithmetic sequence, and that formula is that the sum of the first n terms in an arithmetic sequence is n over 2 multiplied by twice the first term plus n minus 1 times the difference between each term. And we know that in our case, that total is 33,125. Now, do we know n? Do we know a? And do we know d? Let's have a look and see. So we know n because we've got how many terms from 2021 up to 2070. So I'm going to do 2070 minus 2020 to give me 50. So there are going to be 50 terms of this sequence. So n is 50. So it's going to be 50 over 2. Now what's the first term? Twice the first term. So that's twice times 50. Plus n minus 1. Well, n is 50. So that's 49 times the difference between each term times k. That equals 33,125. Now look at that. I've got an equation there which I can use to work out what k is. I've got 50 over 2, well that's 25, multiplied by 100 plus 49k, and that equals 33,125. Well, I'm going to divide both sides by 25 to give me 100 plus 49k equals 33,125 divided by 25, 1,325. Now this is making sense now. Subtract 100 from both sides and divide by 49, and k is 25. Let's just look back at the question. Work out the value of k. I've done it. K is 25. Question 17 looks like a question about surds. Let's have a look. Part A. Show that the square root of 45 plus the square root of 20 equals 5 root 5. So I'm going to take the left-hand side and I'm going to simplify it and hope that I find 5 root 5 is the answer. Now there's a bit of a clue here. You see how we're aiming to end up with an answer which involves root 5s. Well, that kind of tells me that each of these, root 45 and root 20, I'm looking to split them into something times 5. In this case, 45 is 9 times 5 and 20 is 4 times 5. And now, as I hope you know, I can take the 9 and the 4 out of that square root by square rooting them. So the square root of 9 is 3. So the square root of 9 root 5 is the same as 3 root 5. I've taken the 9 out of the square root and square rooted it. I'm going to do the same with the 4 here. The square root of 4 is 2. So the square root of 4 times 5 is the same as 2 root 5. And look at that. 3 root 5 plus 2 root 5 is 5 root 5, which is what they wanted me to do. Part B. This looks like I'm going to be rationalizing the denominator here. So I've got 2 over root 3 minus 1. Now I'm going to multiply top and bottom by root 3 plus 1 in order to rationalize the denominator. Now the top is simply going to be 2 root 3 plus 2. Now the bottom, the denominator. Let's have a look. Root 3 times root 3. Well, that's just 3. Now, sorry, I'll do that in blue. Okay, now, what about minus a root 3 and plus a root 3? That's going. So forget about that. That's disappeared. And now I've just got minus 1 times plus 1, which is minus 1. So what I've got here is I've got 2 root 3 plus 2 over 3 take away 1 is 2. Look at that. Half of 2 root 3 plus 2 is just root 3 plus 1. And it says express it in the form p plus root q. So I'm going to write that as 1 plus root 3. But this version would be 5. Okay, where p and q are integers, yes, p and q are integers because p is 1 and q is 3. Okay, part C. Express this x squared plus 6 times root 2x minus 1 in this form. They're asking me to complete the square, aren't they? So I'm going to focus on these two terms here. Now those two terms, that's x plus, remember you halve the coefficient on the x, so half of 6 root 2 is 3 root 2 squared. Now that's going to give me x squared, 6 root 2x, and it's also going to give me 3 root 2 squared. Now what is that? That's 9 times root 2 times root 2 is 2. So that gives me 18, doesn't it? So remember, I need to subtract away the 18 and then copy down the plus 1. So the yellow expression here is equal to that, and then I've copied down the minus 1. So what this actually equals is x plus 3 root 2 squared minus 19. Okay, that's part C done. And that is question 17. There it is, complete. Question 18. Right, the graph of y equals sine x is drawn on the grid. Yes, it is. On the graph, on the grid, draw the graph of y equals 2 sine x plus 30. Right, now there are going to be two things going on here. The first one, let's just write down the question here, it's 2 times sine x plus 30. Let's first of all just imagine that we were being asked to draw the graph of y equals 2 sine x. What would that look like? Well, essentially, each of the y coordinates, each of the values of y would be doubled, because instead of y being sine x, y is now twice sine x. So the zeros would remain at 0, because double 0 is 0. Now here, this point, sorry, let me make it clear, this point here, instead of having a y value of 1, it would now have a y value of 2. And this point here, instead of having a y value of minus 1, it would now have a y value of minus 2. So that red curve would look like, that wasn't drawn very well, would look like that. So that is the curve of y equals 2 sine x. Now, we're not asked for that curve. We're asked for the curve of y equals 2 sine of x plus 30. Now remember, if the change happens here in the bracket to the value of x, then you move your curve the wrong way. So I'm going to translate my red curve by 30 units to the left. So basically, this point is, sorry, how can I make it clear? This point is going to go 30 units to the left. So it's going to go to here. Meanwhile, this point is going to go 30 units to the left to here. Okay, that's annoying. I've used green again. I'll rub out my original greens. There we go. So now this point is going to go 30 units to the left. So it's going to end up here. And similarly, this point is going to go 30 units to the left. So it's going to end up here. So my new curve is going to be this one. It's going to be there we are. So my final answer is this green curve here, which is the original curve stretched by a factor of 2 along the y-axis and then translated by a vector of minus 30 along and 0 up. Okay, that's part B. Sorry, part A. Right, part B. Write x squared minus 6x plus 10 in the form, I wonder what's happened here. I think that's supposed to read x plus a squared plus b, probably. Right. So I've just got to complete the square here. So I've got x squared minus 6x plus 10. So that's going to be, if I just concentrate on these first two terms here, it's going to be equal to x minus 3 squared. Now that's going to give me an additional 9, so I'll subtract away the 9 and now copy down the plus 10. So that gives me x minus 3 squared plus 1. So my answer is that x squared minus 6x plus 10 equals x minus 3 squared plus 1. Hence, i.e. use your answer to describe fully the transformation that maps the curve with the equation y equals x squared onto the curve y equals x squared minus 6x plus 10. Well, you know that that is the same as the curve y equals x minus 3 squared plus 1. And so now you can read off the vector that you need to translate this curve by to obtain this curve. Right, the plus 1 means that the curve will move 1 in the y direction. And the minus 3, that's inside the bracket. Remember, that means it's going to move the wrong way, so it's going to move 3 that way. So this is, the transformation is going to be a translation by the vector. What did I say? Positive 3 along and 1 up. There we are, by the vector 3 along and 1 up. Okay, good. That is question 18 complete. Question 19. This looks like 3D trig to me. Let's have a look. The diagram shows a cuboid. Yes, it does. EH is 9. Yes, that's marked, and that's marked. Work out the size of the angle between AH. Well, I better draw that. AH. There we go, A to H. Work out the size of the angle between AH and the plane EFGH. Well, that's the bottom of the shape, isn't it? So what I need to do is I need to imagine the sun shining directly above this point, and its shadow would lie here. So the angle I'm being asked for is the angle between AH, which is here, and this line. Look, imagine the shadow of that line. Imagine the shadow of the line AH, and that's where it ends up. So I'm being asked for this angle here. I'll call it alpha. That's the angle I'm being asked for. I've got to give my answer to 3 significant figures. Right, well, I've got a right angle triangle there. I've drawn it in red pretty much. I'll just complete it here. So we've got the right angle triangle, and it is the triangle A down to F, and then along to H. Let me try and draw it again. Right, A down to F, and then along to H. A, F, H. There's the hypotenuse, that's the line AH. This is the angle alpha, that's a right angle. That's 6. Oh, if only I knew what this length was, then I could use tan to find alpha. If only I knew the length of FH. Let's have a look at FH in the diagram here. Here it is. Can I find that by using this right angle triangle, the one that's on the base of the shape? Look at that. Can't I use that right angle triangle? Let's have a look. That's F to E, and then along to H. Now, what do I know about that triangle? I know FE is 5, isn't it? And I know EH is, look at that, EH is 9. So I can find this length here just using Pythagoras. Okay, brilliant. So I'm in business, I think. I'm going to call that X. X squared equals 5 squared plus 9 squared. So X is the square root of 5 squared is 25, 9 squared is 81, so I get 106 there. Okay, so this is the square root of 106. So this is the square root of 106. And now I can use tan and that red triangle there. So I'm going to have tan alpha, tan my angle, is the opposite over the adjacent. Brilliant, I think I've got it now. So on my calculator, I'm going to go 6 divided by the square root of 106 equals, shift tan equals, to give me my answer for alpha. And on my calculator, I get 30.23241 and so on. And so to 3 significant figures, my answer is going to be that the angle is 30.2. And that is question 19 done. Question 20. Question about functions. Right, I'm told what the function f is. I'm asked to work out the f of 5. I'm asked to f5. Let's have a look. Well, the f of 5 is going to be 4 minus 3 times 5. So that's 4 minus 15, which is minus 11. Good. Okay, now g is the function such that the g of x is 1 over 1 minus 2x. Find the value of x that cannot be included in any domain of g. Okay, well, those are values of x which give me 0 there for my denominator, because that won't work in that formula. Okay, so I need to know what x's will make the denominator 0. So what x's solve that equation? Aha, well, I'm going to have 2x equals 1, so x equals a half. So the value of x which cannot be included in the domain is x equals a half. Okay. Part C. Work out fg of minus 1.5. So first of all, I'm going to g minus 1.5, and then I'm going to f the result. Now the g of minus 1.5 is 1 over 1 minus 2 times minus 1.5. You can put that in a calculator as long as you're careful with your signs. It's 1 over 1 minus minus 3. Aha, well that's 1 over 4. So it's a quarter. So the g of minus 1.5 is a quarter. And now I'll have to f that. So I'm going to f the quarter. Right, what was my formula for f? Here it is. It was 4 minus 3 times x. So 4 minus 3 times a quarter. Well, that's 4 minus 3 quarters, isn't it? So that is just 3 and a quarter. And so there is my answer to part C. And that is question 20. Where's it gone? Here it is. And that is question 20 complete. Question 21. The histogram shows information about the birth weights of some babies. Okay, now the minute I see a histogram, I'm thinking here that the area of each of the bars relates to the frequency. And I'm also thinking about frequency density and class width in that formula too. 6 of these babies had a birth weight less than 2.5 kilograms or greater than 4. Right, wait a minute. So, less than 2.5 or greater than 4. So let's draw back. So it doesn't need to be an arrow, does it? So let's draw, here we go, 2.5. So that lot or greater than 4. Okay. So that lot. Right, so 6 of the babies are here and here. Work out the number of babies who had a birth weight between those two. Okay. Well, let's just have a think about these 6 babies first of all. We remember that the area of the bars is related to the frequency. Let's think what the area of this bar is here. Well, it's 5 little squares by 4, isn't it? So it's got an area of 20. Plus, what about the area of this one here? 10 by 1? 10. So 30 little squares. So 30 little squares is equivalent to 6 babies. Okay, well that means that 5 little squares is equivalent or represents 1 baby. So all I need to do now is to work out how many little squares there are here. Okay, and then I can work out how many babies those yellow bars represent, because I know that 5 squares represents 1 baby. So all I've got to do really is to work out how many little squares there are in that yellow block. So let's have a look. And this bar here, that measures 5 by 4, so that's 20 little squares. This bar here, see how high it is, 5, 10, 15, 20 by 4, isn't it? So that's 80 little squares. This bar here, 2 by 25, so that's 50 little squares. This bar here, let's have a look, 1, 2 is 4 wide, 4 by 5, 10, 15. 4 times 15 is 60. So altogether, that is 210 squares. Now I know that 5 squares represents 1 baby, so if I do 210 divided by 5, which is 42, then I know that the number of babies who had a birth weight between 2.5 kilograms and 4 kilograms is 42 babies. And that is question 21 finished. Question 22, a question on functions, right? I'm told that f of x is 3 times x minus 2, and I'm asked to work out f of 5, or to f5. So that's going to be 3 times 5 minus 2. 15 minus 2 is 13. Good. Okay, part B. The function g is such that g of x is 2x squared minus 20x plus 9, where x is greater than or equal to 5. That will be useful to remember later. Express the inverse function in the form g to the power minus 1 of x. Okay, we're going to start off by taking g of x and completing the square. Okay. Well, indeed, what we normally do, of course, is we write y equals x squared minus 20x plus 9, and now we need to make x the subject. And in order to do that, we complete the square on the right-hand side. So I'm completing the square on the right-hand side. So I am going to ignore the plus 9 and write that down later. So I'm really only interested in these two terms here. Now, before I start completing the square, I need a single x squared. So I'm going to write that as 2 lots of x squared minus 10x. And now I'm going to copy down the plus 9. So the yellow expressions are equal to each other. Right, y equals 2, open a big square bracket. I'm going to complete the square on x squared minus 10x. So that's x minus 5 squared, and that will give me an additional 25, so I minus away the 25, close the square bracket, copy down the plus 9. Now it's still the case that those yellow expressions are equal to each other. Now let's multiply out the square bracket. 2 lots of x minus 5 squared minus 50, copy down the plus 9. Now 2 lots of x minus 5 squared minus 50 plus 9 is minus 41. So that's what y equals, and now I simply need to make x the subject of that. So let's add 41 to both sides. I'm going to come up here now. So I'm going to have y plus 41 equals 2 lots of x minus 5 squared. Divide both sides by 2. Y plus 41 over 2 equals x minus 5 squared. Let's write it the other way around. X minus 5 squared equals y plus 41 minus 2. Square root both sides. X minus 5 equals, remember, plus or minus the square root of y plus 41 over 2. Let's add 5 to both sides. X equals 5 plus or minus the square root of y plus 41 over 2. So it looks to me like g, like the inverse function, is going to be 5 plus or minus the square root of, let me write that a bit more clearly, 5 plus or minus the square root of x plus 41 over 2. But be careful, because here you're told, where's it gone? Here it is. Here we are. Here you're told that x is greater than 5. So we can't be dealing with 5 minus anything here. So the only solution you're interested in is 5 plus the square root of x plus 41 over 2, because that means that x is greater than 5. Question 23. Okay, we've got a bowl containing n pieces of fruit. Okay, of these, 4 are oranges and the rest are apples. So straight away, I'm thinking that there are 4 oranges, and if there are n pieces of fruit altogether, then there must be n minus 4 apples. And of course, there's a total of n. 2 pieces of fruit are going to be taken at random from the bowl. The probability that the bowl will then contain n minus 6 apples is a third. Work out the value of n. Now, at the moment there are n minus 4 apples, and we're going to take 2 pieces of fruit out, and then the probability that there are n minus 6 apples is a third. So that must mean that we've taken out 2 apples because there are n minus 4, so originally, so the 2 pieces of fruit must be apples because now there are n minus 6 apples, 2 fewer apples. So what we're actually being told here is the probability of choosing an apple and then an apple is a third. So I'm wondering if we can use that to set up an equation. Let's have a look. Now the probability of choosing an apple and then an apple. What was the probability of choosing an apple in the first place? Well, there are n minus 4 apples to start with out of the n pieces of fruit. So the probability of the first one is an apple is n minus 4 over n. Now we've chosen that one and it's an apple. So now what's the probability of the second one being an apple? Well, by the time we get to the second piece of fruit, there aren't n pieces of fruit anymore. There are n minus 1 pieces of fruit. And how many of those are apples? Well, not n minus 4, but 1 fewer. So n minus 5. So that's the probability of the first piece of fruit being an apple. That's the probability of the second piece of fruit being an apple, and I'm multiplying them to find the probability of the first piece of fruit being an apple and the second piece of fruit being an apple, and I know that that equals a third. And there's an equation which I can solve for n. Now let's have a think about how to do that. Let's start by multiplying these fractions on the left-hand side. On the top times top, n minus 4 times n minus 5, bottom times bottom, n times n minus 1 equals a third. Now, I'm going to multiply both sides of that equation by 3. So I'm going to end up with 3 times n minus 4, n minus 5 over n lots of n minus 1 equals, multiply the right-hand side by 3, I'll just have 1. Now I'm going to multiply both sides of the equation by n lots of n minus 1. So my left-hand side just becomes that, and my right-hand side is 1 times n minus 1. Now this is looking a bit easier now. Let's multiply out, expand those brackets there. N times n is n squared. We're going to get minus 4n and minus 5n, minus 9n. Minus 4 times minus 5 is plus 20. That's going to be n squared minus n. Let's multiply out that bracket on the left. 3n squared minus 27n plus 60 equals n squared minus n. Now this is a quadratic equation, isn't it? Get everything on one side and then factorise. So I'm going to minus n squared from both sides. So now I'll just have 2n squared there, and I've got rid of the n squared from the right. I'm going to add n to both sides. So now I've got minus 26n plus 60 equals 0. Okay, divide everything by 2. N squared minus 13n plus 30 equals 0. Quadratic equation, can I factorise? Well, they're both going to be negatives here, and it's going to be 10 and 3, look, equals 0. So n is 3 or 10. Now, what's the question ask me here? It says, work out the value of n. So I've done that. N can be 3 or 10. What are we thinking about that? Well, be careful, because there's actually, you see it says work out the value of n. It's only expecting one answer. And the reason it's only expecting one answer is because one of these answers, the 3 or the 10, is not a valid answer. And that is because, do you see how we start with n minus 4 apples? Well, n can't be 3 then, because if n was 3, you'd end up with minus 1 apple to start with. Well, that's not possible. So, n equals 3 is not valid. N equals 3 is invalid. So my answer is that n is 10. And that, sorry about all the jumping around, where's it gone? That is question 23 complete. Question 24. Express that as a single fraction in its simplest form. Crikey, they're going to make us work for our marks here. Now the first thing to do is probably to work out that in its simplest form, to subtract those two algebraic fractions. So what have I got here? I've got 4 over 2x minus 5, and I've got to subtract 3 over 2x minus 3. So I'm going to write them with a common denominator. The common denominator is going to be 2x minus 5 multiplied by 2x minus 3. So my common denominator is 2x minus 5 times 2x minus 3. Now the 4 here is going to have to be multiplied by 2x minus 3 minus, careful with that sign, 3 multiplied by 2x minus 5. So let's continue to work on this. Let's multiply out those brackets on the top. 8x minus 12 minus 6x plus 15 all over 2x minus 5 multiplied by 2x minus 3. So that is, simplifying the top, 2x plus 3 over 2x minus 5, 2x minus 3. So that is that bit done. So now what I've got to do is I've got to do my answer to that bit, 2x plus 3 over 2x minus 5, 2x minus 3. I've got to divide it by the second algebraic fraction, which I'm just writing down while I have a think about it. Well, I'm thinking that I'm going to, when I divide by a fraction, I multiply by the inverse, don't I? So the first thing I'm going to do is copy it all down again. And instead of writing divided by, I'm going to multiply by the inverse. I'm going to multiply by 6x squared minus 17x plus 5. That looks like something I could factorize, by the way. Over 9x minus 4x cubed, which again looks like something I could factorize. Now, a bit of technique for you here. I'm going to copy down the first fraction. Now, obviously, I'm expecting to be able to cancel here. So when I look to factorize this, I'm bearing in mind I've got these two, which I might be able to cancel in one of them. So clearly that 6x squared is going to be a 2x and a 3x, because then there's half a chance that I might be able to cancel one of these brackets into the expression. So I'm thinking it's going to be either 2x minus 5 or 2x minus 3. Now, I'm going to hazard a guess it's 2x minus 5, 2x plus 1 there. Sorry, that's not going to work, because that wouldn't give me plus 5 here when I multiplied it out, would it? So it's going to have to be a minus 1 there. Now, let's check our x's there. We certainly get 6x squared. Good. We get minus 15x, minus 2x, minus 17x, and we get plus 5. Good, so that does work. Now, what about the bottom here? Well, I'm going to pull out an x first. It's going to leave me with 9 minus 4x squared. Now, let's keep on going with this. So I'm going to write that as 2x plus 3 all over. Now, I could do some cancelling now, but I'm not going to. I'm just going to write that down. Times by, because I haven't finished cancelling the denominator of this. Sorry, I haven't finished factorising the denominator of this left-hand fraction yet. So I'm just going to concentrate on one thing at a time. Now this is the difference of two squares there. It's going to be 3 plus 2x and 3 minus 2x. Now let's look for cancelling. I can cancel that and that Brilliant. And look at this. I can also cancel that and that. So when I can divide this by 2x plus 3. That leaves me with 1, of course, and cancel there. And now I can cancel here and here. I can't see any more cancelling. So I'm left with the top times the top, which is going to be the 1 times 3x minus 1. So I'm left with 3x minus 1 over. Now I'm doing the bottom multiplied by the bottom. So I've got x multiplied by 3 minus 2x multiplied by 2x minus 3. And there's my denominator. Now, of course, you could multiply out that denominator, but I'm not sure that really makes it simpler. So I'm going to leave my answer to question 24 as that. And that is question 24 done. Question 25. It looks like I'm sketching curves here and translating them and stretching them and things like that. Let's have a look. The curve has an equation there where a is greater than 4. Using the axis below, sketch the curve of C. Right. On your sketch, so clearly in terms of a, the coordinates of any points of intersection with the axes, the coordinates of the turning point. Right. Let's first of all have a think about this. We've got y equals 4 lots of x minus 1 squared minus a. So I've got several things going on here. First of all, I've got this 4 here. I'm going to have a think about y equals 4x squared, first of all. Now, y equals 4x squared is going to look like this. There we go. Okay, it goes through 0, 0, and it is y equals x squared stretched by a factor of 4 in a vertical direction. Okay, now I'm going to transform that blue curve into the green. Right, first of all, I've got this minus a here. Right, here, this. So that is going to shift the blue curve a units down. Okay, so I could just imagine the blue curve being shift a units down. Now I know that a is greater than 4. Okay, so it could just be shifted like this, couldn't it? A units down. But then I've also got this minus 1, so that's going to move it 1 the wrong way, isn't it? So it's going to move the minimum to here. Right, so in fact, the curve that I'm going to be dealing with is that green one. There we are. Now, what do we know? We know that that is minus a. We know that that is 1. So we know the coordinates of the turning point are 1 minus a. Okay, let's mark those. Here we go. Okay, 1 minus a. Good. Now, what about the points where this curve crosses the axes? Right, so here's the equation of the curve. Y equals 4 lots of x minus 1 squared minus a. Now, first of all, let's take x to be 0. Find where it crosses the y-axis. When x is 0, then y will be 4 times minus 1 squared minus a, which is 4 minus a. And we know that a is greater than 4, so we know it's going to be negative, so it's just as well that it looks negative there. So that is the point 0, 4 minus a. So now we're just left with finding the coordinates of the points where our line crosses the x-axis. So we need to solve the equation when y is 0. So we're going to be looking at this equation. 0 equals that. Let's add a to both sides. Let's divide both sides by 4. Let's square root both sides. Plus or minus a over 4 equals x minus 1, and let's plus 1 to both sides. So x is going to be 1 plus or minus the square root of a over 4. So here are the points then. So we've got this point here, which is going to be obviously a positive x coordinate, so 1 plus the square root of a over 4, comma 0. And then you've got this point here, which has got a negative x coordinate, so it's going to be 1 minus the square root of a over 4, comma 0. And that is, I think, my complete solution. Let's have a look. Sketch the curve C, I suppose I could label it, showing the coordinates of any points of intersection with the coordinate axes, done that, and showing the coordinates of the turning point, done that. That's question 25 complete. Question 26. Right, A, B, C, D is a kite with AB equaling AD and CB equaling CD. Let's draw a sketch. So we've got A here. Right, so let's imagine that that's B. Down here, there we go, so that can be C, that's D. We know that AB equals AD, and we know that CB equals CD. There we go, there's our kite. Now what do we know about a kite? Remember, we know that the diagonals cross at right angles, don't they? So, there we go. Okay, now B is the point with coordinates 10, 19, okay? 10, 19. D is the point with coordinates 2, 7, 2, 7, right? Okay. Done that bit, done that bit. Find the equation of the line AC. How are we going to do that? Well, to find the equation of a line, the line AC, we need to know two things. We need to know a point on the line, and we need to know the line's gradient. So that's what we've got to find, right? Now I can already see a point on the line AC. By the way, here's the line AC. I can already see a point on that line because it goes through the midpoint of DB. Look. Ta-da! Goes through the midpoint there, doesn't it? So we can write down D, 2, 7. We can write down B, 10, 19. And we can find the midpoint by finding the average of the x coordinates, that's 6, and the average of the y coordinates, 13. So the midpoint there, which I'll call M, is 6, 13. So I already know a point which the line AC goes through. The only other thing I need to know is the gradient of the line AC. Well, I know that AC is perpendicular to the line DB. So here's D, and here's B. If I could find the gradient of that, then I can find the gradient of AC since it's perpendicular. So the gradient here is going to be, let's do 10 minus 2 is 8, y coordinates first. 19 minus 7 is 12. 10 minus 2 is 8. Look at that. So that's 3 over 2. So that means that the gradient of AC going to be the negative reciprocal of that, minus 2/3. So now I know a point on the line, and I know the gradient of the line. So I can go ahead and find the equation of the line AC. Y equals minus 2/3 x plus c, and I know that y is 13 when x is 6. 13 equals minus 4 plus c, c equals 17. So I know that the equation of the line AC is y equals minus 2/3 x plus 17. But that doesn't completely answer the question because it wants the equation in that form. So multiply everything by 3. 3y equals minus 2x plus 51. Add 2x to both sides. 3y plus 2x equals 51. And there it is in the form that I asked for. And that is question 26 complete. Question 27. This looks like probability. Let's have a look. Jack plays a game with two fair spinners, A and B. Right, so let's have a look at spinner A, can land on those numbers, and spinner B can land on those numbers. He spins both spinners. He wins the game if one spinner lands on an odd and the other spinner lands on an even. Oh, I see. So you could have spinner A odd and spinner B even, or spinner A even and spinner B odd. He plays the game twice. Work out the probability that he wins both games. Wins the game both times. Well, let's just work out the probability of him winning one game, shall we? So if he's going to win one game, then he has to have, it's going to be the probability of A equals odd and B equals even, or the probability of it the other way around, A equals even and B equals odd. Okay, so let's look at the first one here. The probability of A being odd. Well, the probability of A being odd is 3 out of 4. So 3 out of 4 times the and. B being even. Well, the probability of B being even 1, 2, 3 out of 5, isn't it? 3 out of 5. So that's the probability of A being odd and B being even. But he could also win if A is even. Well, A being even is going to be 1/4, and B being odd, well, B being odd is going to be 2/5. So this is, if I work out each of those, top times top, 9 over 20, plus bottom times top, 2, bottom times bottom, 2. Look at that. So the probability of him winning a game is 11 out of 20. So if he plays twice, what's the probability of winning both games? The probability of a win and a win. Well, it's going to be 11/20 times 11/20. So 121. 11 times 11 is 121. Over 20 times 20 is 400. And that's my solution to question 27. Question 28. This looks like a question about series here. Now, the sum of the first 48 terms in our arithmetic sequence is 4 times the sum of the first 36 terms of the first sequence. Okay, that's going to give me an equation, isn't it? And then I've got to find the sum of the first 30 terms of this series. Right, so let's just split the page in two for a moment. Okay, now on the left-hand side, let's do this green paragraph here. The sum of the well, we better remember the formula for the sum of the terms in our arithmetic sequence, which of course is given to you. But here it is. Okay, and let's just remember that A is the first term, N is the number of terms, and D is the difference between the terms. So the sum of the first 48 terms in our arithmetic sequence, well, what's that going to look like? It's going to be sum of the first 48 terms. That's going to be 48 over 2 times by twice the first term, well, I don't know what the first term is, plus 47 times D, and I don't know what D is. So that is the sum of the first 48 terms, and that equals 4 times the sum of the first 36 terms. Well, the sum of the first 36 terms is 36 over 2 times by twice the first term, plus n minus 1 is going to be 35 D. Okay, so I'm going to get a formula here. I'm going to get an equation, with A's and D's in it. I've got 24 times 2A plus 47D equals 72 times 2A plus 35D. I could multiply out those brackets, I guess. So 48A plus 24 times 47, 1128D. 72 times 2, 144A plus 72 times 35. 2520d. So I've got an equation there with a's and d's in it. I suppose I could stick everything on one side, make it easier. So I'll subtract 48a's from both sides. And I'll subtract 1128d's from both sides. There we go. There's an equation with a's and d's. How annoying, though, because I've got two variables there. But there's a secret coming up with this question. Now, let's have a look at this here. The sum of the first 30 terms, well, let's get an expression for that, shall we? The sum of the first 30 terms, well, that's going to be 30 over 2 times by 2a plus 29d. Agreed? Okay. So that is 15 times by 2a plus 29d. Okay. Now, I'm going to leave it like that at the moment, although there's no reason really why you shouldn't multiply it out. But I'm going to leave it as it is. Now, I'm kind of thinking, how am I supposed to evaluate this when I don't know A or D? The thing is, if you go back to the left-hand side, you can use your left-hand side to get an expression for A. Look, if I subtract 1392d from both sides, it gives me 96a. So I'm going to write that around the other way. 96a equals 1392d. Divide both sides by 96, and I get an expression for A. A is minus 14.5d. Now, if I substitute this expression for A into here, it's going to be 15 multiplied by twice A, so that's going to be 2 times minus 14.5d plus 29d. And look what happens here. It's 15 multiplied by twice minus 14.5d is minus 29d. Copy down the plus 29d. Look at that. So you end up with 15 multiplied by 0. 0. So the sum of the first 30 terms, which is given by this expression, is equal to 0. So the answer is, what's the sum of the first 30 terms of the sequence? Sum of the first 30 terms equals 0. So I didn't actually have to find the value of A or the value of D in the end. Question 29. Looks like we're transforming graphs here. Let's have a look. The diagram shows a curve with equation y equals f of x. The coordinates of the minimum point are minus 2, minus 1. Yep, that's marked on the diagram. Write down the coordinates of the minimum point of the curve with these equations. Right, well, if it's y equals f of x minus 5 instead of f of x, remember the changes there inside the brackets, we're going to move the wrong way. So the curve's going to move this way. So that minimum point is going to move 5 units in a positive direction. So it's not going to be minus 2 along anymore, it's going to be 5 units to the right. So that's going to be 3, but it's still going to be minus 1. It's still going to be the same y coordinate. Okay, now let's have a think about this next one here. Now, if y equals a half of f of x, well, the minimum point's still going to be when x is minus 2. It's just not going to go all the way down to minus 1 anymore. It's just going to go half as far. So it's going to be minus 2, minus 0.5. Okay, let's have a look at this question here. The graph of y equals a sine x minus b plus c. Right, so look at this. I've got a stretch there, I've got a movement up or down, and I've got a movement along. Okay, great. Let's have a think. Find the value of a, b, and c. Right, well, let's just have a think about the original y equals sine x. So the original would come here, 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 here. So here's the original. Okay, now let's have a think what's happened here. Well, originally, the original one goes from -1 to 1, right? And this new one has got a bigger range, hasn't it? The range isn't just a range of 2 anymore. The range of the new one, sorry, I should have done that in green, really, because it relates to the range of the green curve. Here's the range of the green curve. And the range of the black curve, it goes from -1 all the way up to 3. Look, the range is doubled, which means it's a stretch of 2, which means that A is 2. Okay, now let's draw the sine curve that's with a stretch of 2 there. Okay, so let's do that now. So I'm going to still go through 0 here, but look, I'll go through here now. Still go through here, but now I'll go down to here. Okay, right, there it is. So now, how do we relate that red curve to the black one? Well, I see the black curve is the red curve moved up 1, isn't it? So that means that the C there must be a 1, because the whole thing's been moved up by 1. Now, the whole thing's been moved up by 1 to here, but it's also been moved along to the right by 90. So that means that we have to pick instead of x, it's going to be x minus 90, isn't it? So b, look, it said minus b, so b would be 90 there. So my new curve, just for clarity, the black curve, has this equation, y equals twice sine of x minus 90 plus 1. And hence those are my answers for A, B and C. Okay, quite a complicated question, but only worth 3 marks. Question 30. Right, looks like probability. Boris has a bag that contains only red and green sweets. He takes 2 sweets from the bag. The probability that he takes exactly 1 red sweet is 12/35. Originally there were 3 red sweets in the bag. Work out how many green sweets there were originally in the bag. Well, let's say that there are 3 red, and let's say there were G green. Now, let's use this piece of information here. Now, that tells us that when he takes 2 sweets, the probability of getting exactly 1 red is 12/35. So that would be the probability of getting a red, then a green, or the probability of getting a green and then a red. And we know that equals 12/35. So I'm thinking that might help us do an equation. Let's have a look at this first expression here. A red and then a green. Well, the chance of getting the first one, well, there are 3 reds to start with, out of how many sweets altogether? G plus 3. That's the total, isn't it? Okay, so that's the probability of choosing a red to start with. Then you've chosen a red. So what's the probability of the next one being a green? Well, now there aren't G plus 3 sweets. There are only G plus 2 sweets. And how many of those are green? G of them. So that's the yellow probability. Plus, now let's do the probability of getting a green followed by a red. Well, to start with, there are G green out of G plus 3 sweets. And followed by a red, well, there would be 3 red out of the remaining sweets, which is only G plus 2. And you know that equals 12/35. Now, can we simplify the left here? Well, let's have a look. You get top times top, 3 times G, over bottom times bottom, G plus 3 times G plus 2, plus top times top, 3G, over G plus 3 times G plus 2. Look at that, they've got the same denominator. And that equals 12/35. So looking at the left-hand side again, altogether I've got 6G over G plus 3 times by G plus 2. And that equals 12/35. Okay, well, let's multiply left and right by this denominator here. So then I'm going to have 6G equals 12/35 times by G plus 3, G plus 2. And now let's multiply both sides by 35. Okay, so that's going to give me 35 times 6G. That's 210G equals 12 times g plus 3 lots of g plus 2. Now this is going well now. So 210g equals 12, open a big square bracket. G times g, g squared. 3g and 2g, 5g. 3 times 2 is 6. Keep on going. 210g equals 12g squared plus 60g plus 6 12s are 72. This is a quadratic. Let's get everything on one side. I'm going to minus 210g from both sides. Minus 150g plus 72. Right, I've got to solve this quadratic equation. I'm going to divide everything through by 6. 2g squared minus 6's into 150, 25g plus 12. Now, I can factorise this, I'm hoping. Let's have a look. G and G. It's going to be a minus and a minus. It's going to multiply to 12. What does multiply to 12? Let's try 12 and 1. See, if I put 12 here, then I get minus 24 G's. And then if I put 1 here, I get minus another one to give me minus 25. So that worked. So therefore, G is going to be a half or 12. Well, I'm thinking having half a green sweet isn't going to work. So I'm thinking that that one must be invalid. So I'm thinking that there must have been 12 green sweets to start with. Let's just look back at the question, check that I've answered it. Here it is. What's the question say? How many green sweets were originally in the bag? 12 is my answer. Question 31. Well, I'm dealing with displacement. Okay, and I'm being asked for acceleration. This is going to be about differentiation, I think. Let's have a look. A particle P is moving along a straight line that passes through a fixed point O. The displacement S of P from O at a time t is given by that formula. Find the value of t for which the acceleration of P is 3 meters per second per second. So I've got an expression for the displacement. So I can differentiate that to get an expression for the velocity. 3t squared minus 12t plus 5. And I can differentiate that to get an expression for the acceleration. That's 6t minus 12. So there's an expression for the acceleration. Now what's the question say? Find the value of t for which the acceleration is 3. So I need to know what value of t, that's the acceleration, what value of t makes it equal to 3? Okay, well then 6t would be 15, so t would be 2.5. So the answer is, find the value of t for which the acceleration of p is 3 square meters, it's 3 meters per second per second. The answer is that the acceleration is 3 when t is 2.5. Question 32 looks like vectors. Let's have a look. ABC is a triangle. Yes, that's marked there. The midpoint of BC is M. Okay, so that's a halfway there, right? P is a point on AM. Yes, it is, right. AB is 4A. That's marked. AC is 2B. That's marked. AP is that, right. Okay, find the ratio AP to PM. So I've got to find the ratio between AP and PM. Okay. Well, let's first of all assume that AP is going to be mu of the way along AM. Okay. So, I don't know, maybe it's a half, maybe it's 2/3, I'm not sure what it looks like. Well, it looks like more than a half, doesn't it? Maybe it's 3/4, maybe it's 3/5, I don't know. But AP is a certain fraction of the way along AM, that's for sure. Now, we've got one expression for AP. Let's find another expression for AP. Now, we're going to do that as being mu times AM. So let's get an expression for AM. and then we'll times it by mu to give us an expression for AP. So we're going to get an expression for AM. So what I'm going to do AM is I'm going to go A to B, and then I'm going to go B to M. That will get me from A to M. Now, so AM equals, now I know AB is 4A. Now B to M is half of the way from B to C, isn't it? So keep on going. A to M is 4A plus half of B to C. Right. So what is B to C? Let's have a look. If I was going from B to C, I'd do minus 4A plus 2B. So that's a half of minus 4A plus 2B. Okay, so AM is 4A minus 2A plus a B. So A to M is 2A plus B. Okay, now remember that AP is mu times AM. So therefore AP is mu times AM, which is mu times that. So AP is 2 mu A plus mu B. But wait a minute, because I also know that AP is 3/2 of A plus 3/4 of B. So look at that. Can't I now equate those coefficients? I've got mu is 3/4 and 2 mu is 1.5. Oh, that's good, because 1.5 is twice 3/4, isn't it? So mu is 3/4. Okay, good. Now, let's go back to see what I was asked for. So we've just decided then that, if I use this, we've just decided that AP is 3/4 of the way along AM. So A to P, that bit, is 3/4 of the whole thing. Right. So if this is A, and that's P, and that's M, then this bit's 3/4. So look, 3 and 1. Now what's the question? Find the ratio AP to PM. Well, it must be AP is 3, PM is 1. So the ratio must be 3 to 1. And that is question 32 done. Question 33. G is the function with domain x is greater than or equal to minus 3. We might need to remember that, such that g of x is x squared plus 6x. Express the inverse function in that form. Okay, so we're going to say that y equals x squared plus 6x. And we're going to make x the subject. So I'm going to complete the square on the left-hand side. That's x plus 3 squared minus 9. Now, let's swap that round. So I'm going to have x plus 3 squared minus 9 equals y, and I need to make x the subject. So plus 9 to both sides. Now square root. So x plus 3 is plus or minus the square root of y plus 9. Now subtract 3, so x is minus 3, plus or minus the square root of y plus 9. Now remember that x has to be greater than minus 3, greater than or equal to minus 3. So we're going to have minus 3 plus something, aren't we? And now I can write it in the form of g to the minus 1 of x is minus 3 plus the square root of x plus 9. So, for my answer here, I'm going to say that x is transformed to minus 3 plus the square root of x plus 9. And that's question 34 done. Question 34. Right, functions. The functions f and g are defined for you there, and the function h is such that h of x equals fg of x. Aha, for x is greater than minus 2. Greater than or equal to minus 2. Express the inverse function, h minus 1 of x. Okay, so first of all, we better find out what h of x is algebraically. Now, h of x is f of g of x. So that's going to be f of, and what's g of x? X plus 3. So we need to f x plus 3. So when we f something, we square it, and we take away twice it. There we are. So let's keep going, shall we? That's going to be x squared plus 6x plus 9 minus 2x minus 6. So that's going to be x squared plus 4x plus 3. So there's an expression for h of x. And I need to find the inverse function. So I'm going to start by writing y equals x squared plus 4x plus 3. Now I'm going to make x the subject. Let's switch it around first. X squared plus 4x plus 3 equals y. Let's complete the square. X plus 2 squared minus 4 plus 3 equals y. X plus 2 squared minus 1 equals y. Let's add 1 to both sides. X plus 2 equals y plus 1. Sorry, x plus 2 squared. Now, let's square root both sides. So x plus 2 equals plus or minus the square root of y plus 1. Now it's minus 2. So x equals minus 2 plus or minus the square root of y plus 1. So that's going to mean that the inverse function looks like minus 2 plus or minus the square root of x plus 1. But look out, because we know that x has to be greater than minus 2. So in fact, we're only going to be interested in the case when x is greater than minus 2. So we're simply going to be interested in the case when we have got minus 2 plus the square root of x plus 1. Okay, and my screen's just frozen, so I'm not going to write that down, but you know that only one of those solutions is valid. Question 35. Right, looks like coordinate geometry. ABC is an isosceles triangle such that AB equals AC. Let's draw a diagram, shall we? So we've got A, B, C. AB equals AC. A has coordinates 437, and B and C lie on a line with equation. Let's have a look. So this line has the equation 3y equals 2x plus 12. Okay. Find an equation of the line of symmetry. So we're trying to find the equation of this line here, aren't we? The line that, there we go, of that black line. That's our target. Right, we've got to find the equation of that black line. Now, to find the equation of a line, we need to know a point on the line, and we need to know its gradient. Well, I can see a point on the black line already. The point on the black line is the point A, isn't it, at 437. Now, what about the gradient of the black line? Well, I do know that the black line is perpendicular to the line CB. And if I make y the subject of this equation here, then I'll have the gradient of CB. The gradient of CB is 2/3. So the gradient of the black line is the negative reciprocal of that, minus 3 over 2. So now I know a point on the black line, and I know the gradient of the black line. So I can find the equation of the black line. So y is going to be minus 3 over 2 times x plus c, and I know that y is 37 when x is 4. So 37 is minus 6 plus c, so c is 43. So the equation of my black line is y equals minus 3 over 2x plus 43. But I have a feeling, yes, look, it wants it in the form px plus qy equals r. So let's multiply everything by 2. Gives me 2y equals minus 3x plus 86. And now let's add 3x to both sides. So 2y plus 3x equals 86. So my answer is that 2y plus 3x equals 86 is the equation of the line of symmetry. And that is question 35 finished. Question 36. Right, looks like we're doing some coordinate geometry here. So let's start by drawing a diagram. So we've got an isosceles triangle, and we've got H, J, and K. Now we know that those two sides are equal. We know that KJ is the square root of 80. Sorry, JK, and we know that H has got coordinates minus 4, 1. J has got coordinates J, 15, where J is negative, and K has got coordinates 6, K. Okay. Well, if J is negative, then I'm going to swap these two around, just so that my diagram makes sense. So this is going to be the point J with J, 15, and this is going to be the point K, which has got coordinates 6K. Anyway, right, I've got M is the midpoint here, and I know that this red line, H to M, has got a gradient of 2. So I've got lots of different pieces of information here. I've got, for example, the fact that that distance is equal to that distance. So I could use that to write an equation, which would involve J and K. And then I've also got the fact that this distance is the square root of 80, so I could use that to write an equation. And I've also got the fact that the gradient of this line from J to K is the negative reciprocal of that. So the gradient of that line must be minus a half. So I've got 3 pieces of information. In fact, I probably only need 2 pieces of information to write 2 equations to find J and K. Right, first of all, let's use the piece of information that HJ is equal to HK, because I know that H is minus 4, 1, and I know that J is J, 15, so I can write an expression for the distance from H to J, and similarly, I know that H is minus 4, 1, and I know that K is 6, K, so I can write an expression for the distance HK, and then I can write those two equal to each other. So let's just have a look at that one. So when we're working out the distance between 2 points, square root of, right, let's do bottom minus top. So J minus 4 is J plus 4. So J plus 4 squared plus 15 minus 1 is 14 squared. So I know that the square root of that is equal to, now let's write an expression for the distance between H and K. Let's do bottom minus top again. 6 minus 4 is 10, 10 squared, plus K minus 1 squared. There we go, let's square both sides. So I know that J plus 4 squared plus 196 is equal to 100 plus K minus 1 squared. Let's leave that like that for the time being. Right, let's use the second piece of information now. Let's cut this in half here. Let's use the gradient information, shall we? So I know that I've got J, which is J, 15, and I've got K, which is 6, K. So the gradient there, the gradient of JK, is going to be the difference in the y's. So let's do the bottom minus the top. So k minus 15 divided by 6 minus j, and I know that that equals minus a half, the negative reciprocal of the line, of the gradient of the line hm. So now I'm going to multiply both sides of this by 2 to give me 2k minus 30 over 6 minus j equals minus 1. Multiply both sides by 6 minus j. 2k minus 30 equals minus 6 plus j. So j is 2k minus 24. Okay. Now look at this. I'm going to take that expression for j and substitute it into here. So there, where I've got j plus 4 squared, I'm going to think about that as 2k plus 24 plus 4. So that is 2k minus 20 squared plus 196 equals 100 plus k minus 1 squared. And now I've got an equation which has just got k's in it. So let's solve it. Let's expand those two brackets there. So 4k squared, it's going to give me minus 40, which is going to be doubled, minus 80k plus 400 plus 196 equals 100 plus, let's have a think, k squared minus 2k plus 1. Right, let's get everything on the left-hand side, shall we? So on the left-hand side at the moment I've got 4k squared and a minus k squared from both sides. So that's going to give me 3k squared. I've got minus 80k there. I'm going to plus 2k to both sides, so minus 78k. Now on the left-hand side there, I've got 596, and from that I'm going to minus 101. Gives me 495. And that equals 0. I bet I can divide everything by 3. K squared minus 78 divided by 3, 26k, plus 495 divided by 3, 165, equals 0. Right, let's factorise k. They're both going to be negatives here. So multiply to a positive, but add to a negative. Now multiplying to 165 and adding to give me that 26. I'm going to try, what's 165 divided by 15? 11, there you go. Sorry, 15 I said, didn't I? So 15 and 11. So look at that. I reckon that k is 11 or 15. So let's work out each of the corresponding values for j, shall we? Now if k is 11, then j, remember that formula there, 2 times k, 2 11s, 22, minus 24 gives me minus 2. And if k equals 15, then j is 2 15s are 30, minus 24 is 6. So it looks like there are two sets of answers. K is 11 and j is minus 2, or k is 15 and j is 6. But remember, didn't j have to be negative? Let's have a look. I'm pretty sure j had to be negative. Yes, it did. So this is invalid. And so my answers are that j equals minus 2 and k equals 11. And that is question 36 done. Question 37 looks like 3D trig, 3D Pythagoras. Let's have a look. Right. AF is 10, AB is 24, BC is 8. All those are marked on the diagram. There are lots of right angles, and they all look like right angles on the diagram. Work out the size of the angle between BE, well, BE is already drawn for me. Here it is, BE, and the plane ABCD. Well, the plane ABCD, that's the bottom, isn't it, of the shape. So I'm looking to work out this angle here. The angle, which I'm going to mark as alpha. And let me just, while I'm drawing in blue, complete that right angle triangle. So that's going to be a really useful triangle, isn't it? Now let's have a look at that triangle there. It's going to be the triangle that goes from E down to D and across to B. There it is. Now that's the angle I'm looking for. That's my target angle. Do I know any of those sides? Oh, I know ED, don't I? Look, I know that's 10. So ED is 10. I'm wishing that I knew DB now. DB, I can find DB. Look at the bottom of the shape. Look at this triangle here. Okay. Triangle on the bottom shape. You go from A to D, and then you go along here to B. That's 24. That's 8. So I can find that length, DB, can't I? DB is going to be the square root of 8 squared plus 24 squared. Right. Okay. 64 plus 24 squared equals, square root answer equals, aha, DB is 8 root 10. So I can write that up here, 8 root 10. And now I'm in a position to find alpha. I can use 10. So if my screen wakes up a minute, I'm going to say 10 alpha is the opposite, 10 over the adjacent 8 root 10. So on my calculator, I use the fraction 10 over 8 root 10 equals, shift 10 equals, and I get alpha is 21.56, and so on. I asked it for one decimal place, so 21.6. Okay, and when I was doing this bit here, I was using this right-angled triangle here. So I hope that was okay for you. And that's question 37 finished. Question 38. All right, I've got to simplify this fraction. The first thing I'm going to do is I'm going to look to factorise the top and the bottom. Now at the top here I can take out an x, which is going to leave me with 6x squared plus 13x minus 5. And I'm thinking that I'll be able to factorise that quadratic again. I'll leave it shaded in yellow for the moment. And that is all over. Now what have I got here? This is the difference of two squares. Look, 4x squared minus 25. So that's going to be 2x plus 5. 2x minus 5. Right. Now I'm having a look at factorising the top again and putting that yellow expression into two brackets. Now do you see how on the bottom I've got 2x plus 5, 2x minus 5. So I'm thinking that one of those is going to cancel. So I'm thinking that I'm likely to have a 2x in one of those brackets on the top. It's either going to be 2x plus 5 or 2x minus 5, I'm thinking. So 3x here. So I'm going to start my attempt at factorising the yellow quadratic into 2x and 3x, just because I'm a bit of a cynic and I reckon I'll be able to cancel. And since I've got 2x on the bottom in both brackets, there's going to be 2x on the top somewhere. Now, minus 5, look. Okay, so it could be 2x minus 5 and 2x and plus 1 there, because that would multiply to give me that minus 5. But would that give me plus 13x? It wouldn't, would it? Because that's minus 15. That's not going to work. It's not going to give me plus 13. It's going to give me minus 13. So I'm going to try, maybe if I make that a plus, and this one a minus. Will that one work? Let's have a look. It's going to give me plus 15x's minus 2x's is plus 13x's. Yes, there you go. So I have factorised that. And that's all over 2x plus 5, 2x minus 5. So now I'm going to divide the top and bottom by 2x plus 5. It's going to leave me with x lots of 3x minus 1 over 2x minus 5. And that is my solution for question 38. Question 39. All right. ABC is a quadrilateral, but it's split into triangles there. I'm thinking sine rule, cosine rule, the trigonometry formula for the area of a triangle. Let's have a look. Right. The area of triangle ACD is 250 square centimetres. Okay. Calculate the area of the quadrilateral. Show you're working clearly. Right, well, first of all, let's have a look at this yellow bit of information here. The area of triangle ACD, that's the area of this triangle, isn't it? Right, so I've got that 39. So I could use the area formula here. So I know the area of a triangle is a half times AB times sine the included angle. So that's going to be sine 39. And I know that that equals 250. So I'm going to have a half times 26 times AC times sine 39 equals 250. Right, so all I've got to do is rearrange that to find AC. So AC is going to be, let's have a look, 250 times 2, then divide by the 26, and then divide by sine 39. And that tells you that AC is 30.55799. Okay, so now I know AC, that one, 30.6, all right, but we'll use the whole equation if we need to later. Right, now, couldn't I now use the sine rule, because I've got that and that, so that and that will enable me to find that side length, and then I can find this angle, and then I'll have that side length, and this angle, so I'll be able to find the area of that second triangle. Add them together, I've got the area of the quadrilateral. So, let's say that AB over sine 47 is going to equal AC, which is 30.55, and so on, over sine 95. So I've got the 30.55799,479 on my calculator. So I'm going to divide that by sine 95 equals times by sine 47 equals. So AB is 22.43407 and so on. So now I can find the area of, let's jump to come back, here we go. I can find the area of this triangle here. Now, before I do that, I'm going to find angle A. Angle A is going to be 180 minus 95 minus 47. 180 minus 95 minus 47 is 38. So the area of that triangle is going to be a half times AB, 22.4, times AC, 30.6, but I'll use the whole number, times sine 36. Okay, so I've got 0.5 times 22.43407 times 30.55799 times sine 36 gives me an area of 201.475. So the area of the whole quadrilateral is going to be the area of the yellow, which was 250, plus 201.475, which equals, to three significant figures, 451. And that is my solution to question 39. Question 40. The line with equation y equals x plus 2 intersects the curve with this equation at the points A and B. Find the coordinates of A and B. Right, so I've got to solve these two equations simultaneously. Now the first equation, y equals x plus 2, gives me an expression for y, which I can substitute into this equation. So I'm going to write x squared plus, and instead of y squared, I'm going to write x plus 2 squared, minus 2 lots of y, so minus 2 lots of x plus 2 equals 24. So all I've got to do is to solve this equation, which has only got x's in it, without messing up the algebra. So x squared plus x plus 2 squared is x squared plus 4x plus 4 minus 2 times x minus 2 times 2 is minus 4 equals 24. Let's tidy up the left-hand side here. 2x squared plus 4x minus 2x is plus 2x. And then I've got plus 4 minus 4, and that equals 24. Set this equal to 0. 2x squared plus 2x minus 24 equals 0. Divide by 2. X squared plus x minus 12 equals 0. Factorise. X and x plus 4 minus 3. So I'm going to get two values for x. X equals minus 4 or x equals 3. Now each of those values of x will have an equivalent, or have a corresponding value of y, and here's my formula for y. So y is x plus 2, so if x is minus 4, then y is minus 4 plus 2, minus 2. And if x is 3, then y is x plus 2, 3 plus 2 is 5. So my points of intersection are, where's it gone? Here we go. My points of intersection are minus 4 minus 2 and 3, 5. And that's question 40 done. Question 41. Looks like I'm dealing with surds here. Let's have a look. The area of a rectangle is 18 square centimetres. The length is that. Find the width. Okay, give your answer in that form. Now the width will be the area, 18, divided by the length. Aha, look at that. So all it's asking me to do really is to rationalise the denominator here. So I'm going to multiply top and bottom by root 7 minus 1. So on the top, I'm going to leave it as 18 times root 7 minus 1. And on the bottom, I'm going to get root 7 times root 7, so that's 7. Then the middle terms will disappear, and then I'll get minus 1. So on the bottom, I'm just going to get 6. Now, the reason I left the top as it was, because now I can cancel really easily. 6 goes into the top. 3 lots of root 7 minus 1 over 1. So actually, this is just 3 root 7 minus 3. And what am I asked for it? I'm asked for it in that form, where a, b, and c are integers. So there's my answer, 3 root 7 minus 3. Question 42. The graph of y equals f of x is shown on the grid. On the grid above, sketch the graph of y equals f of a half of x. So this is going to be a stretch along the x-axis, and it's a half of x there, so it's going to be a stretch of a factor of 2. So let's have a look at this point. This point is 3 away from 0, so it's going to become 6 away. Let's look at this point. This point is 1 away, so it's going to become 2 away. This point is minus 1, so it's going to become minus 2. So here is my sketch of the new curve. Okay, I think I can probably improve on that last bit here. Draw it like that. There we go. Okay. Right, part B. The graph of y equals fk plus x is shown on the grid below. Write down the value of k. Right, well, here's the original. Let's just draw on the original. The original had a minimum here, didn't it? And the minimums moved 3 to the left. So you'd have thought it was minus 3, but you go the wrong way, so it's plus 3. So this k here is going to be a 3. So the value of k is 3. And that is question 42 complete. Question 43. Right, I've got the line L. Here we go. And I've got the curve C. And I'm told they intersect at 2 points. Find the coordinates of these 2 points. Show clear algebraic working. Okay. Right, but I've just got to solve the equation simultaneously, really. Now, L, that gives me an expression for y. So I'm just going to substitute that expression into my equation for C. So I'm going to have x squared minus 3x times y, so 3x times 9 minus x, plus twice y squared, so twice 9 minus x squared, and that equals 0. So x squared minus 3x times 9, so that's 27x, minus minus is a plus 3x squared, plus 2, open a big bracket. Right, 9 minus x squared, well 9 nines are 81. Going to get minus 9x, so minus 18x plus x squared equals 0. Right, so x squared minus 27x plus 3x squared plus twice 81, 162, minus 36x plus 2x squared equals 0. Tidying up, x squared is one of them, plus 3 of them is 4. Ooh, 6x squared, 6x squared. Right, the x's. Minus 27x minus 36x. Well, that's minus 63x. Now, I've just got plus 162. Plus 162 equals 0. Now, 6 won't go into 162, I think. But I think 3 will. I think 3 will go into everything. Let's see. 2x squared minus 21x plus 3's into 16 go 5, carry 1, 54. Okay, equals 0. Oh, I see. 6 would have gone into 162, but it wouldn't have gone into 63. So I was right to divide by 3. Right, now I've got to try and factorise here. 2x and x it's going to have to be, isn't it? Right, it's going to have to be a minus and a minus. Now 54 9 sixes. Is that going to work? If I put the 6 here, then I get minus 12, and the 9 there gives me another minus 9, which is minus 21. Look at that, it does. So x will be 9 over 2 or 6. Now each of those values for x will have a corresponding value of y, because y is, look at this, 9 take away x. So 9 take away 9 over 2 is just 9 over 2, or 9 take away 6 is 3. So remember that the solutions are pairs of coordinates. So one of my solutions is 9 over 2, 9 over 2, and the other solution is 6, 3. And that is my solution for question 43. Question 44. Rationalize the denominator of that fraction and simplify your answer. So I've got a plus the square root of 4b. I see why it says simplify your answer, because I could pull out the 4, couldn't I? And then I've got a minus the square root of 4b. Now if I'm going to rationalize the denominator, I'm going to multiply top and bottom by a plus the square root of 4b. Right. So let's just do that carefully, shall we? So on the top, I'm going to have a times a squared. I've got a times root 4b twice, plus 2a root 4b. And then I've got root of 4b times the root of 4b, which will just give me 4b. Now on the bottom here, I've got a times a is a squared. Now the middle terms will disappear, and then I've got minus the square root of 4b times the square root of 4b, so minus 4b. Okay. So I'm trying to think what I can do now to simplify that. Well, I can certainly simplify the top, look, because I've got a squared, and I can pull out this 4. Now I've already got 2 outside the square root. When I pull out that 4, it's going to square root it, so I'm going to get another 2. So I'm going to have 2 times 2. So I've got 4a times the square root of b plus 4b. And all of that is over a squared minus 4b. And that is my solution for part A. Right, let's have a look at part B. Part B. Given that, okay, well I think I'm going to rewrite the left-hand side using powers. So instead of the square root of y, instead of the square root of y over x, I'm going to write that as y to the power of a half over x to the power of a half, and that is the power of minus 5. Okay. Oh, well look, I can get rid of that negative power just by swapping the fraction round. There we go. So that is now to the power of 5. Now wait a minute. If I've got x to the power of a half to the power of 5, then I just multiply the powers, don't I? In the same way, I multiply the powers. So that's going to be x to the power of 5 halves over y to the power of 5 halves. So what is m? M is equal to 5 halves. Okay, that is question 44 done. Question 45. Looks like vectors. Let's have a look. Right, A, B, C, D is a trapezium. Okay. DC is 3 times AB. Okay, so those are the two parallel sides then. We're going to have AB, and DC is 3 times that. So it's obviously the longer parallel side. And so the trapezium then is going to look something like this. Okay, now I'm told that D to A, that's this vector here, is minus 2, 3. I know it doesn't look like minus 2, 3 on the diagram, but never mind that. Okay, and I'm also told that D to B, which is this vector here, is equal to minus 1, 7. Okay. Right, find the exact magnitude of BC. Okay, well, if I can find AB first, then I can find DC by multiplying AB by 3. So let's think about A to B. Well, to go from A to B, I'm going to go AD, that's down here, and then DB. So plus DB. Now I know AD because it's this one backwards, so it's 2 minus 3. I'm going to add on D to B, which is minus 1, 7. Okay, so AB is 1, 4. So therefore, DC is 3 times that, right? So DC is going to be 3 times 1, 4 is going to be 3, 12. So D to C, here we go, it's 3, 12. Now what am I asked for? B to C. Well, let's see, I can probably do B to C now. Let's see, if I'm going to do B to C, then I can go from B to D, and then D to C. Now B to D, I know, is the opposite of that one, the negative of that one, so 1 minus 7, plus DC, DC is 3, 12. So BC is the vector 4, 5. Okay, now I'm asked the magnitude of that vector, aren't I? So the magnitude of BC will be, let's write that a bit more clearly, the magnitude of BC will be the square root of 4 squared plus 5 squared, which is the square root of 16 plus 25, which is the square root of 41. So that is the exact magnitude of BC. Question 46. A triangle has sides of length 8, 10 and 14. Okay, so 14, that can be the long one, 8, and then 10. Find the size of the largest angle. That's going to be that one there, the one opposite the longest side. Call that one A. I'm going to use the cosine rule here. The cosine rule rearrange. So cos of A will be B squared plus C squared minus A squared over 2BC. So in this case, cos of that angle at A will be 8 squared plus 10 squared minus 14 squared over 2 times 8 times 10. Right, on my calculator, I get cos A then is minus a fifth. So now I do shift cos equals, and I get the answer of 101.5 to 1 decimal place. Right, question 47. The diagram shows a cone. Yes, it does. AB is the diameter of the cone, V is the vertex. Given that the area of the base of the cone, okay, well that's pi r squared, the ratio of the area of the base of the cone to the total surface area of the cone, well the total surface area of the cone is the base, the area of the base, plus the area of the curved face, which is pi r l, where l is that length there. And we know that ratio is 3 to 8. Work out the size of the angle AVB. AVB, we're looking for that angle there. Okay. Right, so we know that pi r squared over pi r squared plus pi r l is 3/8. Now, I can simplify that to fraction there because I can divide top and bottom by pi r. Leaves me with an r here. If I divide the bottom by pi r, then I get r plus l. And I know that equals 3/8. Now, if I multiply both sides by 8, then I get 8r over r plus l equals 3. And then if I multiply both sides by r plus l, I get 8r equals 3 lots of r plus l. So 8r equals 3r plus 3l. So 3l equals 5r. That's interesting. So now I know the ratio between the length, the curved length, and the radius. The radius is 3/5 of the curved length. So I've got this triangle here, this right angled triangle. If I go down to there, and to there, and to there, I've got a right angle here. That's R, and that, just a minute, we can do better than that. Call that L, because R is 3/5 of L, so that's 3/5 there. Now, if I can use that to find this angle, then that, I don't know why I'm calling it alpha, because it's not, that's half of alpha, isn't it? But I'll call it x. So let's have a look. It's going to be sine, isn't it? Okay, and sine of x is going to be the opposite, 3/5 L over the hypotenuse L. So actually sine of x is just 0.6, 3/5. So I just need to inverse sine 3/5 to get what x is. So 0.6 equals, shift sine equals, so x is 36.869. So alpha is going to be twice that. Times by 2 equals, and put that answer to one decimal place, 73.7 degrees for alpha. Question 48. The diagram shows a sketch of part of a curve with the equation y equals fx. Okay, there's one maximum point. Yes, there is, and that's marked at 4, 6. Oh, okay, the coordinates of this maximum point are 4, 6. Write down the coordinates of the maximum point on the curve with the equation y equals f of x plus 4. That's going to be this curve moved 4 in the wrong direction, so move 4 that way. So it's no longer going to be 4 along and 6 up. It's going to be 4 in that way. So it's not going to be 4 along anymore and 6 up. It's going to be 0 along and 6 up. Okay. What about this one? Y equals f of 2x. Okay, well, this is going to mean that instead of the maximum being when x is 4, the maximum is going to be when x is 2. So the maximum is going to, because then 2 times 2 gives me the 4. So it's going to be at 2, 6. Okay. Right. The equation of a curve C is that the curve C is transformed to curve S under the translation 4, 6. So it moves 4 this way and 6 up. Find the equation of the curve S. You do not need to simplify the equation, right? Well, the horizontal movement is 4 to the right. So you'd have thought it was plus 4, but it's a horizontal movement, so it goes inside the bracket, so it goes the wrong way. So it's not going to be x squared anymore. It's going to be x minus 4 squared plus 3 times x minus 4 plus 4. Right, now what about dealing with this movement? The curve is translated by 6 units up, so I'm going to have a plus 6 at the end here. So, well, it says here, find an equation of the curve S. You do not need to simplify the equation. So I think that that's my answer done. Okay, and that is question 48 complete. Question 49. The diagram shows a cuboid. Yes, it does. Now, I'm told the ratios of the sides here. Then I'm asked to find an angle. I'm asked to calculate the angle between AF, here we are, AF, and the plane ABCD. Well, that is this angle. It's the angle between AF and AC. Imagine the sun shining in the shadow of that line from A to F. It would fall to there. So I'm being asked for this angle. Now I'm being asked the angle, but I'm only given the ratios of the sides. But I might as well take those as the side lengths, because if I know the ratios of the sides, then any triangle will have the same angle if the sides are in that ratio. So the length of AB is 4. The length of BC is 2, and the length of CF is 3. Okay, well, I'd really like to be dealing with this blue triangle here. Let's draw that blue triangle. Here it is. Right, so it goes from A to C and then up to F. A, C, F, right angle there. That's 3. I wish I knew what AC was, because then I could use tan, if only I knew what AC was. But let's have a look at this triangle on the bottom of the shape, on the base of the shape. Look at that. It looks like this. A to B is 4. B to C is 2. So I can use Pythagoras to find A to C. Okay, so A to C here is the square root of 4 squared plus 2 squared. So that's the square root of 20. So this is the square root of 20. So now I can use tan here. So tan of alpha is the opposite over the adjacent. So I simply, on my calculator, have to do 3 divided by root 20 equals shift tan equals, and give my answer to 1 decimal place. 33.9 is what I get for question, what is that? Question 49. Question 50. Here is a triangle, ABC. Yes, it is. I'm given some information there, and I'm asked to calculate the value of x. Now I'm thinking, can I use the sine rule? Because I've got that and that, but I don't have that and that, or that and that. I'm wondering if I can find one of those, though, to help me out. So I'm going to find this side here, the side B, and I can use the cosine rule for that because I've got the 2 sides there and the angle 110. So B squared is going to equal 4.1 squared plus 5.3 squared minus 2 times 4.1 times 5.3 times cos 110. So that gives me B squared is 59.76 and so on, and square root that, and I get B is 7.73073 and so on. Right, now I know that that length is 7.73 and so on. So now I'm feeling like I can use, let's have a look. I've got, so now can I just use a sine rule? I don't see why I shouldn't, because I can simply say sine of x over 5.3 equals the sine of 110 over 7.73 and so on. So that means that sine of x is going to be sine of 110 over 7.73 and so on times 5.3. So I can get the sine of x on my calculator. That's about 0.644 and so on. Shift sign equals, and I find that x to three significant figures is 41.1. And that is question 50 finished.